Hello and welcome to today's mathematics class. For this class, we'll consider the study of Pascal's triangle, a method under Binomial Theorem. Last class, we'll consider the first method under the study of Binomial Theorem called the general method. So if you're interested in watching our initial class, right, Binomial Theorem introduction, where we use linear method. If you'd like to watch the previous class video, I'll drop the link above you here. So click on the link above you here, take it to our initial class, where we use the first method called the general method. Here is now the second method called Pascal's triangle. How does this work? By definition, Pascal's triangle is simply a method used in binomial theorem which gives the coefficient of terms in an expansion. So the main function of Pascal's triangle is to give the coefficient of terms in an expansion. That's your definition. Last class, we look at several examples such as a plus b all squared, a plus b all cubed, a plus b to power 4. We look at how we can actually expand these three things using general method. Similarly, we'll pick these three examples and solve them using Pascal's triangle, and at the end of the class we'll try to compare our answer if they are the same. Aside that, we'll look at some past questions that we can actually use the concept of Pascal's triangle to solve, and we'll see what we get. All right, when it comes to the study of Pascal's triangle, there is a pattern of arrangement of number which we'll be using in the study of Pascal's triangle. So I'll be giving you this pattern of arrangement of number right now. So master the arrangement of number, right? So don't cram. I don't believe in cramming. I believe in mastering something. Just know how it works. So I'll give you a table, let me call it an arrangement of number that work with Pascal's triangle, right? So your first task for the arrangement of number, your first task is to what? Start with 1. Next up, 1, 1. Next up, 1. Combine these 2, 1. Next up, start with 1. Combine these 3. Combine these 3. Combine these 3. Combine these 3. Next up, 1. Similarly, start with 1. Combine 4. Combine 6. 4, 1. Start with 1. Combine 5, 10, 10, 5, 1. Let's stop at this point. Start with this 1. This is 6. This 15. This 20. 15, 6, and 1. So, and it's continue in this pattern, right? So, here's what we refer to as the concept of the Pascal's triangle. Observe that this thing looks like a triangle in shape. Observe the pattern. It looks like what? A triangle in shape. So this like your arrangement that I was saying before that you have to master. So this arrangement of numbers start with 1. Start with 1. 1, 1. 1. Combine this 2, then 1. Start with 1. Combine this 3. Combine this 3. Next 1 and this. Start with 1 again. Combine this 4. Combine this 6. Combine 4. Stop at 1. Start with 1 again. Combine this 5. Combine 10. Combine 10. Combine this 5. Then start with what? 1. Start with 1 again and end with 1. Always start with 1, end with 1. Start with 1, end with 1. Add this 2. 2. Start with 1, end with 1. Add this 2. 1, 2, 3. 1, 2, 3. So that becomes your pattern of arrangement of number. These numbers here are called the Pascal's triangle coefficient. So what do I mean by that? So where are we meant to use 1? Where are we meant to use 1, 1? Where are we meant to use 1, 2, 1? Here's a concept, please. For the first one there, for the first one, which is 1, if I have a plus b, for instance, power 0, whenever the power or the index or the degree is 0, the Pascal's triangle coefficient I will use is just 1. For this one here, if the degree or the power or the index is 1, I'll use 1 coefficient. Similarly, for this one here, if I have a plus b all squared, if the power or the index or the degree of the expansion is squared, I'll use 1 as my Pascal's triangle coefficient. For this one here, the same concept, a plus b, in this sense, if I have cube this way, if the index or the power is cube, I'll use the coefficient 1, 3, 3, 1. Similarly, for this one, if I have a plus b all to power 4, if the degree is 4, I'll use 1, 4, 6, 4, 1 as my coefficient. For this one, I have a plus b all to power 5. This becomes my Pascal's triangle coefficient that I will be using, right? Similarly, for this last one there, if I have a plus b all to power 6, this becomes my coefficient, which is 1, 6. And just place very well this 6 here and put 1 here. So I have 1, 6, 1, sorry, 1, 6, 15, 20, 15, 6, 1 as my Pascal's triangle for an index of degree that is 6. So this becomes, it's continuous this way. We have for the 7, 8, 9, 10, it's continuous this way, right? So and here's your concept here. So let's take some example to further explain how we use this pattern of numbers. So example 1, we said we're going to be using our last class example and compare our answer if they are the same. So let's start with this one here, a plus b squared. Last class, when we expanded this, we had our answer to be a squared plus 2ab plus b squared. After expansion using the general method, we had this. Let's now see when we use Pascal's triangle if we are going to have the same answer. So first, how do we solve this one using Pascal's triangle? There are two key things to note when it comes to expanding via Pascal's triangle. The first thing is that pick out the first term such that the first term carries all the power and the second term is left with nothing. That's the first task. Your next task now is that you will reduce the first term by 1 and increase second term by 1. What do I possibly mean? Let's do this, please. I'm told to expand a plus b all squared. This is equal to, said, pick out the first term a such that it carries all the power, that's squared. This second term b is left with nothing. That's my first task. Since this is plus, I'll have a plus sign here. We said reduce the first term by 1, that's a to the power 1, right? If I reduce 2 by 1, that becomes 1. Similarly, increase second term by 1, that's this is 0. Increase by 1, that is you're adding 1 to it, that's 1. Next up, plus, same procedure, reduce the first term by 1, a to the power 0, increase by 1, b to the power 2. Observe I'm having square here, and my question was in squared, so I'll stop at this point here. So at this point, I stop now. What's the next task? My next task is to recall my indices concept. What's the indices concept? I mean, if I have a to the power 0 and a to the power 1, at this level now, we should know the answer to this. S to the power 0 is of course 1. S to the power 1 is that thing. So anything to the power 1 is that value there. So for me, I'll apply this concept here. I'll have a squared into s to the power 0 is 1 plus a to ab. S to the power 1 is that thing. So ab plus a to the power 0 is of course 1 into b squared. Expand through, this gives a squared plus ab plus b squared. At this point, I can't leave my answer in this form. It's wrong. Why? because I'm using Pascal's triangle, I have to go and recall my coefficient. Observe that this is squared. This is squared. What's the coefficient? That's 1, 2, 1. So at this point, I'll say using Pascal's triangle coefficient. So what's my coefficient there? That's 1, 2, 1. So I have 1, 2, 1 as being my coefficient for the I star. 1 is 2. So the coefficient there is what? 1, 2, 1. We said 1, 2, 1 there. We said I'll pick out this 1, attach it to this, pick out this 2, attach it to this, pick out this last one here, attach it to this. All I get there, that becomes, if I expand a plus b all squared, that will give, we said pick out this 1, that's 1 into a squared plus, this is second term, I'll be pick out 2 into ab plus, this is 1 into b squared. Expand through, what do I get? That's a squared plus 2ab plus b squared. This is what I have. So observe my answer. When I use Pascal's triangle, I had the same answer when I use general method. Observe that these are the same thing. So this becomes how your Pascal's triangle concept works. So this is how it works. This is Pascal's triangle for you. Let's do a second example to further explain the in-depth concept behind Pascal's triangle, right? So let's say example 2. Example 2. Let's say I have a plus b to power 3, for instance. So my first thing, I know that I'm using Pascal's triangle, and my coefficient, this is cube, this cube. So I'm using what? 1, 3, 3, 1 as being my coefficient. But before that, let's try to simplify this. We said if I have a plus b all cube this way, we said, what's your first priority? Pick out the first term, that's a, such that this a carries all the power, that's cube, and the second term b is left with nothing. This is a plus sign here, I'll have a plus, of course, plus. Next up, we said reduce the first term by 1, that's a squared. If I reduce 3 by 1, that's squared. Increase by 1, b to power 1, plus the same procedure continues. Reduce by 1, a to power 1, increase by 1, b squared. Similarly, plus, we said reduce by 1, a to power 0, increase by 1, b cube. So I'll stop at this cube and cube here. This is squared, what is it? Square, sorry, square and square. I'll stop there. Cube and cube, I'll stop there. So what's the next task? My next task now is I apply this concept here. So said this becomes b a cube into 1 plus a squared b plus a b squared plus 1b cube. At this point, what do I get? Observe that x plus 0 is 1, x power 1 is that value, x plus 0 is 1. So what I get here, it becomes a cube plus a squared b plus ab squared plus b cube. I can't leave my answer in this form. What next? Using Pascal's triangle coefficient. So at this point, using Pascal's triangle coefficient. So if I use my coefficient, what do I get? My coefficient for cube, right? My coefficient for cube, of course, is what? 1, 3, 3, 1. So I'll have a 1, 3, 3, 1, right? So attach them to each value here. So if I expand a plus b all cube, what do I get as my answer? We said attach, this is 1, or let's say 1 times a cube, that becomes a cube plus 3 times a squared b, that's 3a squared b, plus 3 times ab squared, that's 3ab squared, plus 1 times b cubed, that becomes your b cube. So this becomes how to expand this concept using Pascal's triangle technique. So at this point now, I understand this basic concept now. Let's try to solve some past questions. Let's for instance, this is a and b. A and b are just simple. What if I'm having 3x plus 4y? What if I'm having 3x plus 4y all squared? How do you expand this? So let's say we're not using a and b now, we're using something like this. How do you possibly expand this? So let's look at this concept very shortly. Let's work on example 3. For example 3, let's say we're told to expand 3x plus 4y all squared. How do we possibly expand this? It's quite a simple process. Let's use Pascal's triangle here and let's see what we get. We said for Pascal's triangle technique, say pick out the first term such that the first term carries all the power and the next term here is left with nothing. So said to solve this now, I'll start with this. I'm having 3x plus 4y all squared. We said to expand is quite simple process. Pick out the first term. My first term here is just 3x alone, right? So that it carries all the power, that's squared, and the next term, which is 4y, is left with what? Nothing. I'm done. Now focus on this. Focus on your increasing and decreasing. Reduce this by 1, that's 3x to power 1. Increases by 1, that's 4y to power 1. Reduce by 1, that's 1. Increase by 1, that's 1. Plus, continue the same concept of increasing and decreasing. Decrease by 1, that's 3x to power 0. Increase by 1, that's 4y to power 2. 2. I'll stop at this point, please. Right, so what's the next task here? At this point now, my next task obviously is to take you guys back to your indices concept. What do we know from now? From indices, we know that if I have AB, for instance, or to power C, to express this becomes A to power C, B to power C. So this power here will affect each of these terms. So apply this technique here too. This becomes 3, this square will affect 3 and x. That becomes 3 square x square for this one alone. This one becomes 4 to power 0 y to power 0. This 0 affects each individual term here. Plus this becomes 3 to power 1 x to power 1, right? Into this becomes 4 to power 1 y to power 1 plus 3 to power 0 x to power 0. Similarly, 4 squared y squared. So it becomes your concept here. At this point here, what's the next task? 3 squared, of course, is 9. Then x squared into this is x to the power 0 is 1, multiplied by x to the power 0 is still 1, right? So of course I can just say let 1 to be here to save time, plus at this point now, what's your next task? So this because x to the power 1 is that value, so 3x here into 4y plus x to the power 0 is 1, so having 1 here into 16y squared. 4 squared is 16, y squared remains y squared. At this point, let's expand through. 9 times 1 is 9, but an x squared is there, plus 3 times 4 is 12, that's 12, x times y, xy, right? Plus this times 16 is what there? 16y squared, y squared. I can't leave this as my answer, it's wrong. Why? Because I have not used my Pascal strand coefficient. For square, check what's the coefficient there? Square 1, 2, 1. So I'll say using Pascal's triangle coefficient. So my coefficient there is 1, 2, 1. For a square, I have 1, 2, 1. So we said combine each of them with it. I'll have 1, start with this 1, which is 1 here, into 9x squared plus, this is 2, into 12xy plus, this is 1, into 16y squared. Expand through, this gives 9x squared plus 24xy plus 16y squared. So if I expand 3x plus 4y power 2, I'll have 9x squared plus 24xy plus 16y squared as being my answer after expansion. Let's do one last example, then proceed to the third method called the combination method. Welcome back. Let us take this last example and end this concept of Pascal's triangle, then move to the next class or perhaps next video series where we discuss the concept of combination method. All right, at this point now, check out the series example I've been doing under the study of Binomial Theorem. Observe that all my terms down I am trying to expand are all plus 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 plus. So let's consider a negative sign. So let's say if I have a negative sign, how do you possibly evaluate that? How do you simplify that? So let's take an example to further explain that. So let's say I have 2x squared plus 3y all to power 3. Sorry, you said negative, please. So let's say we are to expand this. So how do we evaluate this? So we have been doing evaluating plus plus plus. Let's not consider minus. How does it work? So my task here is quite simple, right? My task is quite simple here. Let's try to expand this and let's see what we get. Yeah. All right, let's expand this, please. From here, I'll have an equal to, you said, pick out the first term, that's 2x squared, so that carries all the power, that's cube, right? Into the second term is 3y, is left with what? Nothing. Now, mind you, am I meant to put plus or minus? Observe, am I putting plus here or minus sign? By the way, this 3y This minus is for 3y, right? So I meant to put minus here because I meant to put minus here. So if you have to put minus here, so it means that for every 3y, there must be a negative sign attached to it. So if you want negative sign to attach to it, you don't need to follow my procedure now. But to avoid confusion, let's say let's ignore the negative sign for now. Let's work with this. Just pick out your 3x, 3y perhaps. Left with what? Nothing, Abi. Now, observe that there's an invisible plus here. Invisible plus. So that becomes plus, next up, minus. So becomes plus, minus. So minus. So that reduces by 1. That's 2x cubed, 2x squared into by 1, that's squared, into increase by 1, 3y to power 1. Next up, this is plus, minus, plus. We said reduce by 1, 2x squared all to power 1, increase by 1, 3y all to power 2. Next up, plus, we said reduce by 1, 2x squared all to power 0, increase by 1, 3y all to power 3. So this is 3, this is a cube here. So I'll stop at that point. At this point here, what the next task? This is now equal to, we said apply your indices concept. It becomes 2 to power 3, next up x squared into this 3. I have this one, right? This one is for this. Into this becomes 3 to power 0, y to power 0. Oh, sorry. Of course, observe please. Plus, minus, plus. Yes, meant to minus. Minus sign should be here. So note that whenever you're having a minus sign, just do it normally. But here's the concept. Start with plus, minus, concept, right? So let's get this done, please. This is now equal to, minus. Apply the same concept here. This gives 3 to the power 2, right? Then x2 into 2. I'm done with this one. So into 3 to the power 1, y to power 1 for this. Plus, minus, plus. So I have a plus sign here. This 3 to the power 1, s is s into 2 into 1. So I have this one for this. So into 3 squared, y squared. Minus, let me put the minus here. Minus. For here I'll have into 3 to the power 0, x squared into 0. I have this one here. So this is 3y cubed. That becomes 3 to the power 3, y to the power 3. All right, I have this one here. What's the next task from here? My next task from here is quite simple. What do I do next? This is now equal to, this will be equal to, this power 3 is 8. Then x, 3 times 2 is 6. So I have this one as being this, into x power 0 is 1. So I have 1 here. Minus, this one gives 4x to power 4. That's for this. This will give 3y. X power 1 is that thing. So 3y plus into 3 power 1 is 2. X 2 times 1 is 2. That's x squared. For this 2 times 1 will give 2. So x squared. I have this here. Into 3 squared is 9. Y squared. Right? So for this one here, it becomes minus into 2 power 0 is 1. Right? This is 2 times 0 is 0. That's x power 0. X power 0 is 1. So my answer there becomes 1. This one becomes 1. Then into, this is 3 to the power 3. That's 27. Y cube. Y cube. Let's expand through and let's see what we get. For me, I'll have 8 times 1 is 8x to power 6 minus 3 times 4 is 12x to power 4y plus 2 times 9 is 18 x squared y squared minus plus minus plus minus 27y cube. I can't say this is my answer. It's wrong. It's not my answer yet. So what do we recall now at this point? Recall what? Your Pascal's triangle coefficient. So at this point, I'll say using Pascal's triangle coefficient for raised to power 3. What's the coefficient there? 1, 3, 3, 1. So I have 1, 3, 3, 1. So what do we get as our answer? We said multiply each of them by this term there. Start with 1. This 1 here is this 1 here into 8x to power 6 minus this is 3 becomes 3 into 12x to power 4y. I have this one. This 3 becomes a plus 3 into 18x squared y squared minus this 1 into 27y cube. Expanding through, what do I get? This gives 8x to power 6 minus 36x to power 4y plus 54x to x squared y squared minus 27y to power 3. This becomes my answer after expanding this term here using the concept of Pascal's triangle. So see you in the next class where we discuss the second method called the combination method. If you're interested in assisting us, right? So I'll drop my account detail, or perhaps I'll drop an account detail in the description of this video, right? So if you're interested in assisting us or donating towards the cost of this progress of this learning, simply reach out to us by sending a little bit or any amount you have to that account number, right? Or perhaps you can reach me out through my WhatsApp number, right? So thank you very much. Welcome to Excellent Link Academy. Stay tuned. Follow us on our Instagram page, TikTok, and Facebook page. So see you in the next class. Bye.